Welcome to all of you, my friends. So today we will explain the most interesting problem, and which is actually related to the non-linear space, right? So let's start this problem with the concept of non-linear space. First of all, we will explain what is non-linear space. Non-linear space means, suppose I am taking a vector space X. This is a vector space, right? Now this vector space X is called non-linear space if there exists, or if it is possible to define a norm. It is possible to define a norm from X to R. R means set of real number, right? So if it is possible to define a norm from X to R, then this is called the non-linear space. And this norm satisfies the following properties. The first property is norm X always greater equals to 0 for all X belongs to X, and norm X equals to 0 if and only if X equals to 0, right? The next condition is for any scalar A. For any scalar, suppose the scalar, I am denoting this alpha. For any scalar alpha, this is a scalar alpha X, norm equals to mod alpha norm X for all X belongs to capital X, right? The next condition we need to be satisfied by the norm. And next condition 3, this is called the triangle inequalities, is equals to this, right, for all X, Y belongs to X. So a vector space, or you may call linear space, this space with this norm defining this is called the non-linear space. Therefore X, this is NLS, in short form non-linear space, right? Now here R to the power n with the norm be a non-linear space, and where the norm is defined as like this way, mod xm, where m lies within 1 to m, then prove that the open wall Bxr is convex. Now what do you mean by the convex? What is the concept of convex? So let's define the concept of convex with the help of geometry, right? Convex means, suppose I take a set X whose geometrical figure is like this. This is the geometric figure of this set. Now the set X is called convex set if the line segment joining any 2 points in this set lies within this set, right? And in mathematical notion, suppose xy belongs to X, 2 points X and Y, this is X and Y. Now the line segment xy, this is denoted as tx plus 1 minus ty, where t lies within 0 to 1. This is the line segment. If this line segment lies within the interior of this set, then the set X is called convex. This is the concept of convex. So here I am here, suppose the set like this. Is it convex? No, this is not convex because there exists a line which lies outside of this set. This is the inside portion of the set, right? But this lies outside portion. Therefore, it is not a convex set. The set will not be convex. Now define. So I draw a set like this. Suppose circle, right? So it will be convex because any line taking 2 points within this, it always lies within this set. So similarly, the rectangle, it will be convex, square, convex, right? These all figures are convex figure. Now start to solve this problem. Norm equals to this. First of all, we take n equals to 2 for simplicity. Actually, to understand what is actually happened in two-dimensional case, So I think it is more easier to understand what has happened with this set for n equals to 2. So for n equals to 2, norm x, what is norm x? Norm x equals to max of, so this is xn with mod 1 less equals to m less equals to 2, right? So this is our norm. Now from this norm we will try to define this unit ball B01 ball, because if it is possible to draw this ball B01, then we can construct BXR, any arbitrary ball, with the help of this ball, and that's why this, you may call this as the basis of this, right? So you can construct any other ball using this ball. So here we will construct this ball B01. So for B01 ball means this is you can consider this as a circle with radius 1 and center origin, right? So this is our B01 ball. Now this B01 ball, actually from here it will be B01, this is equals to maximum mod x less than 1 and mod x1 less than 1, mod x2 less than 1, right? This is our open ball using this definition of norm. From this definition we can construct this open ball. Now try to draw this open ball, right? So here mod x1 less than 1, so mod x1 less than 1, this actually gives the square, right? Mod x1 less than 1, that means 1 0 minus 1 0, this is 0 1 and this is 0 minus 1, and this is x1, this is x2 axis. This is very simple. Mod x1 less than 1, that means the this actually is x1 lies within minus 1 to 1, right? And similarly x2 lies within minus 1 to 1. So that's why the figure will be this, and we have already told that this is a square, and square figure means it will be convex, right? Therefore from here we can conclude that B01, this is convex. So this B01 is convex. Now since this B01 is convex, then we can conclude that BXR, the open ball, will be convex. Now why? Because just look at this. From this ball B01, this is our B01 ball. Now contract this ball, right? Contracting this, the figure will be, this is our figure, and suppose here I am taking this as R plus R, so this is R0 point, this is minus R0 point, and similarly x1 x2, and this is 0 R and this is 0 minus R point. Therefore this ball will be 0 R ball, right? Contracting this, so after contracting this we will get this figure. Now translating this, translate this, so after translating in the distance x, after translating in the distance x, we will get the figure like this, and suppose this is x and this distance is x distance, this total distance is x distance. Therefore this will represent the ball BXR ball, right? So from this basis, that means B01 ball, we get this ball, and from this we get this ball. Therefore since this is convex set, therefore it will be convex, and this is also convex set. So that's why we can conclude that BXR, this will be convex, right? BXR will be convex. And if we generalize this, so here we have proved for n equals to 2, right? We have proved for n equals to 2. Now if we generalize this for n equals to 3, n equals to 4, n equals to 5, then we will get the same thing, same result. For n equals to 3, you will get a cube. This will be the cube. And similarly for 4 dimension, 5 dimension, up to n dimension, the theorem holds, right? So that's it, my today's concept. I think you all are enjoying my class, and I will try to understand the whole concept using the geometry. And in my next class, I will try to explain the next part and the other matrices using the geometry like this. So that's it today. I will stop here. Thank you.